Welcome to today's webinar. I am Jeffrey Palermo, your host, and I'm really excited today to be talking about the present topic, which is why executives and developers speak different languages and how to bridge the gap. It's a really, really important topic, and it's not a new topic. It's one that's been around for a long time. And my goal is that in your organization, in your projects, you can bridge that gap and ultimately you can have a more effective software project and get down the road and meet your business objectives. A real quick housekeeping to get out of the way. We have a really healthy group of software leaders in the list here attending. And my commitment to you is that whatever questions that you pose on the Q&A window, I'll make sure that those questions get worked in and answered either throughout the content or even I don't care how long I have to stay after the fact. And if some of you we need to go a one-on-one session and just talk about the situation, that's perfectly fine too. We're here to help. A little bit about ClearMeasure. We're a software engineering firm, and we're also the software development partner for quite a number of clients. And we serve companies that are building business critical software solutions. And we love fixing projects, turning around projects, making them better. Projects that are so important, they have to go well. So that's who we are. We focus on software that uses Microsoft technologies, and you can see some of our industry partners on the left-hand side. We have a few resources, the Success for Business Critical Software Projects mini book, and also the Software Leaders Handbook, and you can find those on our website, clearmeasure.com. And ultimately, we want to empower every software project, the people involved, the companies that are funding them, and a lot of times the managers whose career is riding on these, empower those to be world class and accomplish all the business objectives that they set out to do. Another resource, if any of you would like a free electronic copy of my latest book, .NET DevOps for Azure, then you can just send me an email or put the request in the chat. Chloe is online, kind of assisting me with the logistics of the webinar, and we can get you an electronic copy of this book. And so that's available to you. I don't have a slide for it, but I also host a podcast called the Azure and DevOps Podcast. And you can find that in any of the podcast directories. If you just search for Azure or if you search for DevOps, it's kind of reliably in the top 5 results for that. And we bring really interesting guests every week to talk about how to ship software successfully on the Microsoft platform. But today's webinar, here's the agenda. Recognizing that executives and developers speak different languages, we're going to dive into why, and we're going to talk about tactics and solutions to bridge that gap. So we're going to talk about the problem. We're going to look at the problem from the developer's perspective. Then we're going to look at the problem from the executive perspective. And when I say executive, I'm speaking about any level of management that is involved with the decision of whether or not we should fund this project. They don't participate in the team. They are outside the team. And so I consider, even if you have someone whose job title is software development manager or lead engineer, if that person leads the team within the team and daily is engaged with every member of the team, well, that's on the team perspective. And so when I say the executive perspective, these are the people who are not in the team engaged with every member of the team. These are people who are outside the team, and their view is more on objectives and how much the project is costing. Okay. Uh, then we're going to talk about some things that are often tried that don't work. Then we're going to dive into the solution options, and of course, provide some next steps for how you can immediately start tackling this challenge that most software projects have. All right, let's talk about the state of the problem. So uh, we have some data from the 2015 Chaos Report, and the Standish Group puts out reports. On, I mean, on some cadence. There was another report that had some information on project management in 2020. If you've never even looked at those reports, I recommend that you do it. But after over a decade of agile adoption, the Standish Group put together in 2015 some findings and analysis of what that movement did, and found that the projects using Agile did succeed on an average rate about 3 times better than waterfall projects or big phase processes, and that sounds great, and it certainly is, but that's not the whole story. And um, you can read the report, but agile projects still were only deemed a success 39% of the time across all project sizes on average. And only by looking, just at the segment of small projects does the track record jump to 58%, which is great, but still only 58%. In small projects, if you look at it, really small projects, waterfall succeeded 44% of the time, which is again less than half. And experience tells us just intuitively that the smaller the project, the easier it is in general to succeed in the first place, even if you don't have a clear methodology, right? The smaller things are, just the easier they are and the lower the risk. But a logical question to ask is, why don't we just do small projects all the time then? But we'll leave that for a later time. We have other webinars that kind of dive into architecture and project decomposition. And if you don't follow our webinar series, then I'd recommend that you do that. But with this very poor industry track record, we need to understand how to spot a project that is failing right away so that we stop it. And while Agile certainly is better for projects, Agile still only succeeds around 25% of the time for the medium and large size projects. And success in this report was defined as on time, on budget, on target. But if you look at the large project sizes, Agile still only succeeds 18% of the time. I think a better definition for success is that the executives that funded them are so glad that they did. And a definition of failure is that the executives who made the decision to invest all of that money, they wished they hadn't done it. And if that's the case, that's a failure. Okay. It didn't meet the expected return on investment. And so we need to understand this, because if it weren't for this very poor track record that's out there in our industry, we really wouldn't have this problem with developers and executives speaking a different language. And you could kind of dive into what's the chicken or the egg, or what's the cause and what's the effect. Is the failure rate the cause for developers and executives not speaking the same language, or is the not speaking the same language contributing to the failure rate? Of course, I think the not speaking the same language is the contributor to the failure rate. So if we move upstream, if I'm right about that, then we need to move upstream and solve that problem. So let's boil it down. Small projects, okay, easier all around. But we're still looking at over half of software projects failing just in general. And for the large software projects, the ones that end up over 500,000 lines of code, that's KLOC, 500,000 LOC lines of code. If once we get to software that is the size where you're tipping over 500,000 lines of code, over 70% of those projects are failing. They cannot be considered a success. Even if they finish, they cannot be labeled a success. Okay. Um, and for so many businesses, custom software makes or breaks the business. Okay. I mean, you can see some recent ones. Southwest Airlines is a completely different player in the market now than before the big software catastrophe that kind of grounded thousands of flights over Christmas of 2022. I mean, in the whole marketplace, that just they are seen as a different airline because they had a massive software breakdown. So, okay, let's look at this from the software developer's perspective. All right, and by the way, I'm pausing to make sure that I have the Q&A window open so that as people ask questions, I can work that in. But let's look at it from the software developer's perspective. Software developers are the ones with hands on keyboard, typing the code, and we have to deal with the computer. Computers are precise. We have to give them explicit instructions, and there's a whole lot of jargon. Okay, and some of the language when things are not going right, when an executive comes in and starts asking questions and putting pressures like, why isn't this done? Why isn't this done? Or why are these bugs? Then, developer, might talk about that. It's like, hey, I'll tell you when it's done. If I tell you when it's done, I'll just be wrong. So stop asking. Or, I might say, um, I'm doing something that has never been done before. If it has been done, then just go buy a license for it. Or questions might come in. I might say, look, just go to Jira or go to Azure Boards or go to GitHub. All the information's there. You have access to it. Why are you asking me? Or I might give an excuse. The people that you hired before me left a big mess. I need to have time to clean it up. Can the new feature wait? So from a developer's perspective, we're in the trenches and we're having to deal with the computer and um, that's just kind of the perspective. Now, from a business executive's perspective, I'm going to put on that hat before. I'm sitting outside and I'm seeing things that are not moving as fast as I want. I'm seeing quality problems, things breaking. I'm seeing disruptions in production. The things are having to be fixed. The production system is having hiccups, causing people not to be able to do their work. And so, from an executive perspective, I'm saying, look, time is money. The longer it takes, the less return on investment we're going to get for even commissioning the project in the first place. I'm starting having second thoughts, or maybe I say, the software is only one piece of the strategy that's not on track. We have a ton of things we're doing, a part of the strategy. And if the software is not ready or if the software is not right, then the whole strategy is going to fall over. Or I might answer about budget. We can't add another developer. It's not in the budget. And of course, I'm asking, hey, when is this going to be done? I don't even know when this is going to be done because the last time that I was told it was going to be done, it hasn't happened. And I don't even have a new date. And so when's it going to be done? Or in response to, bug reports, a bug that was labeled, oh, this is a minor bug. Well, that minor bug just cost us a lot of money. Or I may say, I just have no idea what's going on. I haven't received a status report in ages. And the last status report, I don't even know how to read it. Or I might say, shoot, I'm so frustrated. Maybe we just need to fire the whole team and start over. All right. That's a business executive's perspective. All right. So there's some things that are often done that don't help at all and they don't work. One is just blaming the developers, thinking, oh, the managers out there, the executives, they don't understand this and blame them. And the executives are thinking, man, what are those? What's the development team even doing? Are they even working? Blame does not work. Also, what doesn't work is expecting the other to change while thinking, oh, there's nothing wrong with me. I don't need to change anything. Also, what doesn't work is getting communication consultants or just, throwing out platitudes or trying to send developers to some business training or trying to send executives to technical training. That doesn't work. Okay. Let's talk about how to solve the problem and close the gap. All right. The big the big thing here is we need to adopt a common model or a process. All right. Um, and if you look at any organization that has a multi-stage workflow, a multi-stage assembly line, if it were. Everybody understands how it works and why it works and how it's put in place, even if the management chain doesn't actually personally know how to jump onto the assembly line and operate every one of the stations and move work around. They understand that the station is there and why it's important. And so we have alignment on what the process is. The key word is alignment. You want alignment between developers and executives and everyone in between. And when we have a common model for work, a common process, we need to control that process and we need to measure the process. And that common process and the measurement of it creates motivation and engagement for developers, and it creates clarity for executives. So that is super, super important. So let's dive into what the heck that means. A business-oriented, highly technical software process really is the solution so that everybody involved can share the same language. And of course, Clear Measure, we have an approach to that, and we call it the Clear Measure way for effective software teams. And we give away resources for free. Think of it as it has education curriculum, it has tools. Our core belief here is that when equipped and trained properly, we believe that every team, every software team can be successful. And so what the Clear Measure Way does is simplify and synthesize known practices in a manner that any software team can implement. And we have free tools for assessing the state of the software project, for aligning the team with a document template, and also a template for a team scorecard in Microsoft Excel, so that you can start measuring the things that matter and reporting them to everyone who needs visibility. So let's talk about aligning. Aligning on what? Well, we need to align on a number of things here, and so we're going to go through. We need to align on purpose, align on product, align on process, and then align on schedule, align on location, align on people. We're going to go through them one at a time, and they kind of answer the question: why, what, how, when, where, and who. Okay, all of those general questions applied to a software project. So let's kind of dive into the why. First, align on purpose. And we need to make sure that everyone understands why the company funded the software team and the software project to begin with. Why did it happen? And make sure every developer, every analyst, every person involved in the software team knows that. Every executive and member of the management chain agrees and understands why the team was funded and the project was commissioned. We need to know why the company would continue funding the team, or what would change so that we just say, you know what, it's not worth it anymore. Let's stop this and do something else. Also, why we're building the software, and then if you need a resource to kind of help you out, you can download the team alignment template from our website. And if you do need help, you can just put a question in the chat, and Chloe will help you out with that. That's the why question. And a lot of the misunderstandings are the executives and developers not having the same answer when asked, why are we doing this? Okay. The next question is what? What are we doing? That's aligning on product. And so we need to answer the piece parts of this question. Do we have knowledge on the market we serve? Do we know what that market is? And what needs are we meeting? What market needs are we supplying a solution for? What needs are we choosing not to meet of that market? What does our customer need next after this particular software product or software features? And then what features did we build last time that never got used? In other words, there was no return on investment, so that we can learn from it. And the free resource that we have available to help you answer the what question is the vision section of the team alignment template. But it's really important that everybody have absolute alignment on the product that's actually being built. And that's, of course, answering the what question. What are we doing specifically? And making sure we know what we're not doing as well. Next question is how, and that is process. We're aligning on process. And not only the how of how we're going to do the techie stuff, but the how of the customer, how the customer is going to use things. How does the market know about the software? How does the market know that it's out there, that it's available, and how does the market adopt our software? How does a customer request features or maybe report problems with it? How do we, as the company, prioritize the next feature or maybe test new features? How does the software team design new builds or design new work as it flows through the process? How does a developer write code? How does the developer deliver bug-free pull requests? And we have a resource available for that. I'll show it to you on the screen, but I actually have a big life-size version of our DevOps architecture poster that I'm kind of showing on the camera. And I'll show you in detail, but this is available to you if you'd like. I'll talk about that in a few slides. So that's another free resource available to you. Um, and so this is the top 1/3 of that poster that I just held up. And I know some of the text is really small, but it's a high resolution PDF if you get it digitally. And it's meant to be, taken to a print shop and printed on architecture D paper, 2 foot by 3 foot poster board and hung up on a wall in your team area, or even an individual office. And so if you'd like the high resolution PDF version of that DevOps architecture poster, then just go ahead and request it in the chat, and Chloe will help you get it. But it's also available as a free resource on our website. And it's a highly shrunken technical blueprint for the structure and flow of a pipeline that's implemented with Azure DevOps services and other best of breed tools like Octopus Deploy and Azure. And it shows the structure of the industry standard continuous delivery flow with continuous integration for builds and saving off release candidates and um, artifact repositories like the NuGet server that is in Azure Artifacts. Whether you're using Azure pipelines or GitHub Actions or JetBrains TeamCity or whatever, there's a number of tools out there that work just fine, but the process is the same. And then, of course, we need the deployment part of the pipeline, and there's patterns for that too. You always need a minimum of 3 environments. There's 3 categories of environments. You have production, you have a manual test environment, and then you have an automated test environment. Those are the 3 categories. And sometimes you need more than one of each. You might need 17 test environments if you have a highly complex area where you have different groups of testers that need their own environment that they can test with. And that's fine. But you need at least one. You need at least one environment where people can kind of check out the software and make sure it's right. Just like production, some companies have more than one production environment for different constituencies, different regions. That's fine, but you need at least one. And then the first environment is your test automation environment for the 3-letter acronyms. I like to call it the TDD environment to invoke the visual of test-driven development. This is the no humans allowed environment where we're just going to deploy automatically to it the next build that comes out, and we're going to run through all of the full system tests, and we're going to make sure that none of the tests failed and our software is still stable. And then we're going to run the next build. So there's no point in a human ever trying to access this environment to use the software, because the data is just getting loaded and ripped out, and builds are getting redeployed. And it's really just meant for automation so that we can have that third stage of the continuous integration pattern. We find a lot of teams say they are using continuous integration, but they're only implementing one of the 3 stages of continuous integration. And the integration build is the most popular stage of the continuous integration pattern, but it's only one of the 3. Going way back to the book that defined continuous integration back in 2006, you have the commit stage where you have a private build that runs on an individual developer's workstation. Then you have your integration build, which runs on a team shared environment. And then you have your first deployment and post-deployment testing. And that's your third stage of continuous integration. And only then do you know that you have actually integrated changes from multiple people and have the confidence that you have a stable version that can be pushed forward. But this is available to you. This is the technical part of a common process. And this isn't just a technical process. The executives need to know that this is the DevOps process that we're using so that they have visibility and can ask questions about it. Also, the pull request process and how we work in full system testing. This flow is important as well. And you can see on the left-hand side, the horizontal bands are where a particular process happens. The top horizontal band is in design and validation outside of a developer's workstation. And then we have processes that work on the engineer's workstation, and then the process that happens on the build server, and then the processes that happen on the bottom band on the TDD environment. And this flow is really critical in preventing and finding and removing defects. And so if we want defect-free release candidates pushing into our manual test environments, then a process like this is really important, where we define test scenarios ahead of actually writing code. And then right after leading into our pull requests, we verify that those test scenarios have in fact been automated and they pass, and that we work in inspections into our pull request. So there's a lot of detail. We've done some other webinars diving deeper in here, but it's important that you actually have a published process that everybody has visibility into. Okay. The next question is when, and that is aligning on schedule. And there's multiple parts to this. Some questions that we need to answer are: when is the market event where we need to have the software ready? Is there a date? Is there a trade show? Is there a conference? Is there contractual agreements where we absolutely have to have a new capability available because bad business things happen if we don't make a certain date? And armed with that, there's so many things that we can do on the software side to make the date, even if all of the behavior that we really wanted to be a part of the feature isn't quite done. We can figure out how to make a date. Every feature has like the barely minimally viable feature that just works to satisfy like the function, and then all the additional capabilities of a feature so that it's super easy to use, self-training, all the good things, perfectly observable. So if we know those deadlines, well, now the development team can align with the executives on that urgency, and then the executives can ask more intelligent questions about what's gonna risk that deadline. We also need to answer questions like by when does a customer need X in order to secure their business if we're selling to a new customer? When is the cutoff date after which the new feature no longer provides the expected return on investment? Also, when can this feature be delayed so that we could prioritize something else? Can we switch things around? Maybe we can. We also need to answer the question where, and that's aligning on location. Where is our market? Where are our users? Not only physically, but also digitally, and also the development team. Where will the development team work? What kind of office environment? Where will the team produce work, and where will the work be placed? Digital systems are also part of the work environment. So if we're using Azure pipelines, if we're using Octopus Deploy, if we're using a particular region in Azure, those are digital systems that are part of the work environment. And we need to know the importance of them because sometimes if there's some type of outage, well, guess what? It's pretty useful to have executives aware that the development team was just hindered because a particular outage happened, and that's critical to the work environment, right? And then where will the software operate? Could be smartphones, could be desktop, could be cloud, private client data centers, could be just a web browser. So we have some resources available for that. One of our services is an architect retainer where we come on as one of our architects provides advice on an ongoing basis, and we can push you in the right direction. We can ask insightful questions, and it kind of provides fractional software leadership. And those are very, very affordable, and it makes sure that that software projects don't go along just unnecessarily blind to something. And so it brings some of those things out, and that can be useful to you. Next question is who? Who's doing what? We need to design the team to the outcome. We need to tailor the outcome to the available team and decide who's going to do what. Um, who's the user, who's the customer, who's going to support the software, who's going to build the software, who's going to design the software, who is going to envision the software for the overall market. And of course our team alignment template helps define those. But let's get really tactical on this. Um, and by the way, this is not just this is not development team details. These are executive details. And so I know we have a really good mix on this webinar, and I can kind of sense, yeah, some people are nodding. It's like, yes, yes, we don't have anybody who clearly is the person who is designing the software or one of these other categories. But for you executives out there who employ developers and who are writing the check that funds a software project, this is part of the foundational structuring of a software project organization so that everybody is aligned. And if we get tactical, work tracking boards like this will emerge from it. And this gives you instant status on every bit of detailed work that is flowing through the project team at any moment. And um, a quick hint, if you look at your work tracking system and you've got three statuses, one is not started, one is in progress, and one is done, then you have no way of knowing what actual status of anything is at any given time or when anything is going to be done. You need to actually give visibility to the major types of work in the basic software development lifecycle. And of course, over the last almost 25 years, Agile has changed the industry to work in a one piece at a time process through the software development lifecycle, as opposed to taking large batches of features and trying to move them through all in large batches. So Agile shrunk the batch size way, 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 way down, and really mature Agile teams are down to a batch size of one. Whereas for a long time, the batch size was, oh, we're going to have a 2 week sprint, and we're going to have, some number of backlog items or user stories, and we're going to work in a batch. And through that sprint, we're going to try to get that batch into production. Well, teams that have gone through that stage and continue to mature realize that, okay, well, 2 week sprint, that's just like an arbitrary batch size. Why? And then they go down to a 1 week batch size from just an organizational perspective. But from a technical perspective, they've kind of shunned the notion of an iteration or a sprint altogether, and really just have single 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 feature or single backlog item batch sizes, and any individual item can move through independently, and you just keep things flowing through. The most mature teams just naturally arrive at a batch size of one. Then the question is decomposition and work assignment. So if we have a development column in the middle of our board where the code is actually written, then we naturally have to break items down in that process. But there are four distinct design decisions that have to be made in order to write the proper code. And the first one is, what the heck are we building? That's concept definition. And we need to have a specific stage for where we're thinking about what the heck this feature actually is, defining the concept. And then there's another decision in order to write the appropriate code. We have to figure out how someone's actually going to use it. Um, and not just what they're going to look at, because a lot of software features don't even have anything to look at. If you're just processing data under the covers or moving data from computer A to computer B, there's plenty of software behaviors and features that don't necessarily have anything to look at, but you're always going to have some way for a user to experience the goodness that we want. For example, we might want, I don't know, some text message notifications to pop up, if certain things happen. Or we might want data to be moved from A to B within 5 minutes. And it would be a very poor user experience if the data took 6 hours to get where it needed to go. So we need to make decisions about how will a user actually get the benefit from this change. And then after that, we have to make the decisions about what technologies to employ, what architectural elements are necessary, what design patterns should we use, and that goes into the technical design. We need to make all the decisions about how we should be making this new user experience a reality in the software system that we currently have, and also making a decision whether a particular feature would cause the sprouting of a separate software application and a separate code base. You know, we have to ask that question. And that's where also we start breaking features into smaller features, because oftentimes a feature is too big to just say, okay, now let's give this to a developer and just start working on the feature, because invariably the developer is not going to have the complete design. And once we do have a complete understanding of the appropriate design, we also tend to have a complete understanding of all the pieces that need to be implemented. So those go hand in hand. The next decision we have to make before we write the code is, how do we know that we're done? And what are all the different behavioral scenarios that this feature needs to support? From the simplest login screen, you have a happy path where good username and password, they get logged in, or a exception path or a sad path where the wrong password, you get an error message, you don't get logged in. So through every piece of software behavior, every feature, there's multiple behavioral scenarios, and we need to list out what those are. After we've done the technical design, we have the complete analysis necessary to understand all of the unique pathways of behavior. And so we need a test scenario for each of those behaviors, because if we give it to a developer and the developer instantly says, okay, I'm done. Well, what is the list of things that I need to check to validate the assertion of I'm done, right? So that's the column, that's the stage where we do it. And the back half of the Kanban style board is basically validating the design decisions up front. After development, we do our functional validation at the team level to make sure that all the software works, the TDD environment, and a team level manual test environment. Then user experience validation, probably someone in product management or someone that's close to the customer, does some manual testing and make sure the intended user experience plays out. And then after that, release validation, that's doing all the techie stuff to make sure that we are prepared to support and operate this thing, this new version, this new feature in a production environment and be able to support it. Okay. So if you look at this as a flow, there are lots and lots and lots of activities that happen. There's analysis that happens. There's technical design that happens. There's QA that happens. There's release engineering that happens. There's make pretty, UI design and color decisions that happen. There's all kinds of work that happens, but this is defining the flow and the order in which things happen, not the category of functional task. Okay. All right. Um, so we had a question come in. Um, where does the QA process happen? The QA process, half of it happens in test design, defining the test cases, defining the test scenarios, and then in functional validation and in user experience validation, we we make sure that all of the expected behaviors are in fact there, and the expected user experience design is in fact there. So the every bit of validation naturally is coupled to its analysis pair. And so you have the decision of what it should be ahead of coding, and the validation of did we make it like that after coding. And so um, testing or QA, and people talk about it in different ways, defining what it means to be good happens ahead of coding, and verifying that it's as it should be happens after coding. And that's why it's important to make these design decisions and then have all of those design decisions validated after the code is written and before we push it into production. So hope that answers that question. Okay. Um, the next thing that we want to imbue into our software project is a concept of reporting out and reporting up. And when you think about a status report, or just think about a report in general, you want to accomplish a few things. You want the business to continue funding the software team and the software project. Therefore, you want the executives to see that, guess what? There is a return on this investment. You want to show that the business needs are being met. You want to show that ROI. Um, it also accomplishes the retention of developers, and not only from an employee satisfaction perspective, but um, A players love succeeding, love winning at the game of software. It's fun and it makes it worthwhile to stay at the company. All right. Also, every department in business produces regular reports that kind of answer these questions. And a regular report always has a scorecard, always has metrics. Business runs on numbers, it runs on measures, all the way to the financial numbers of, is the company making, a dollar of profit? If a company is not making profit, then the company is dying. That's just the way it happens. And so everything a company does is distilled down in financial statements, which are reports of numbers. And so every activity that the company does, including software development, it needs to have a report that has numbers. And so um, our team scorecard template, it provides some examples of those, but the most basic forms are around quality, stability, and throughput. And so, some of the numbers with every piece of software, you want to track your defect rate, defects that were found before it went out to production to customers, and then defects that escaped out to production to customers, and then the mean time to fixing bugs that were found, so that we know how quickly we can turn around and fix those bugs once they are found. Those are very, very basic measures that are very popular out in the industry. And also stability. How did we have an outage in production? Did we have a minor issue in production that was still, something that we had to fix, but that didn't cause an outage? And what was our mean time to recovery when we had an issue? I mean, those are basic metrics. And then on throughput, how many items are going through our development process, through our Kanban board? How many items are going through? Of course, we can slice and dice that by status to see bottlenecks. But we can start to measure the throughput of the team by just counting. And so just those basic numbers, you've got a scorecard. But across some general themes happen across the clients that we help, and almost universally, The projects where we come in and things are off the rails and we have to come in and play the turnaround artist, one of the first things that we see is if there are status reports being given to management at all, they lack any numbers whatsoever. If the status reports even exist, they're just some text of like, oh, here's some things that we're doing, and it's just English. There's no numbers. And high performing teams, by and large, the reports that are given, yes, there's a little bit of English to analyze it, but the reports start with the numbers, and then the English words provide some interpretation of the numbers. Those are the most effective reports. And so, given that a software project represents such a massive investment, software projects are not small investments. Software projects are big investments. We need world-class reports. And so the general structure of a report starts with numbers and then follows up with English commentary, analyzing and interpreting the numbers. Okay. So, need the report. So important. So important. All right. So, what are your next steps? This is a big, this is a big topic. Without the right process, executives and developers are not going to be aligned, are not going to be speaking the same language. Executives can't ask intelligent questions, and the developers will feel like they're communicating, but the understanding is not matching. And it all comes to a head when the dates that the executives need are not happening, or the development team isn't getting what they think that they need from the executives. It goes both ways. It's not just one-sided. But to bridge it, you need the right process, and the right process yields the right information, the right report. And so the next steps, there's a few things that you can do to continue your studying on this topic and others. One is if you are a lead engineer or the software architect of a particular project, if you're a technical leader in a software project, then we invite you to join our architect forum. It happens once a month. It's with other people who are running teams that are shipping software with Microsoft technologies, and it's a peer group where everyone learns from each other. I facilitate that group on a monthly basis. If you are a manager of one or more teams, or are in the executive chain that has a custom software organization, then we invite you to join our upcoming software leadership forum. And we are publishing the details of that very, very soon. And so look out for that. But that is for you. That is for people in the management chain who are running significant software projects. And so that forum will be upcoming. You can also request a free one-on-one strategy session with a chief architect at ClearMeasure, and that's no cost to you. That's just some free advice. Bring an issue, and we'll push you in the right direction. And then, of course, you can use our online resources. They're all free. I've talked about a number of them as I went through the webinar. Go to our website, check them out. Chloe has provided some links in the chat as well, and they're all free to use. And if you need some outside help, and right away that you want to hire ClearMeasure, then I've listed out some common engagement types. They're all under the banner of making your software project world class, making it really well. And so first and foremost, we love coming into projects that are not exactly like they should be. Whether or not they're already late, okay, we'd love to come in and help you get it back on track. If there's some risks, or you don't quite know how to get it on the right track, even if it's not on fire at the moment, we love coming in and helping with that. If you're just not sure, but maybe suspect something, we love doing software organization assessments or software inspections where we can get into the architecture, inspecting the software process, and looking at your current strategy for platform engineering. And also, we love coming alongside the leaders who are running these software teams and running these software projects and doing some advisement and mentoring. So you can email me, or you can email info@clear-measure.com. And there's a number. If you are a team that is shipping software using Microsoft technologies, then we love serving teams like you. And as we get to the end here, I think I've answered all of the questions in line. So thank you for all of those are very good questions that came through. And if there's no other questions that come through, thank you so much for your time and attention. We really appreciate you taking the time out to come and study with us. And check out the Azure and DevOps podcast, as well as the next webinar series. And um, we hope you have a very, very successful software project, whatever you're currently building. So thank you so much, and have a terrific Tuesday. God bless.